So I was playing with those degrees of freedom and degrees of freedom analysis in simple cases. Regarding what Johnson wrote, that the nut was following the washer. So I do not follow basically this idea, because in other places there is a statement that constraints are bidirectional and there is no master and slave component in constraints, so why should a nut follow the washer and not the opposite? And here I have prepared an example. So we have three components: global position, global coordinate system. This is a stationary reference for us to see what is happening, and this is used as to constrain local coordinate system. This is this small triad here. This indicates some local coordinate system, some element that is constrained with the master. So the constraints are as follows. So the mate or the mate or flash. So basically the XYZ to have it. This stands for translation along Z axis, translation about along X axis, and translation about Y axis, and rotation of the coordinate system. I can just present it to you. So we just skip the part for a moment. So let's drive it, and let's see, 40, 50, 0. And you see this rotates 0, let's say 270. This rotates the system about z-axis of the main coordinate system. So we got back to 0. So this is constrained to that, and we have a part that represents our geometry, and this part is constrained to the local coordinate system in the similar manner. So this is translation about z of the local, this is translation about x of the local, and this is translation about y of the local. And this is the angle as before, rotation about z of the local coordinate system. If we drive that, let's see, 270, then this drives this along this axis here. So just a quick straightforward assembly of the elements. And now currently design degrees of freedom analysis shows 0 degrees of freedom, and if we show the degrees of freedom, there are none. I will now suppress the X translation. So the X translation is now possible for, this is for the local coordinate system, and as we can see here, the X, the local coordinates, I mean, maybe I will just make it a little longer. So for the local coordinate system, we have the indication of the degree of freedom, so translation along this axis here, and for the part we have the indication cube. This indicates, when I just go here, just a second ago it was showing me the local coordinate system that it was constraining to. So basically this part now is indicated as following the local coordinate system. Whether the part is following the system or the system is following the part, it is questionable, but still okay, this indicates this is moving with something else. If we go to the degrees of freedom analysis, we have indicated only the translation degree of freedom for the local coordinate system, so this is this triad, and we have none indicated for the part. This is related to the part that it is indicated as following. So oh yeah, now it is, as you can see in the left in the tree, it indicates which element is this following. So this is straightforward situation. Now what I will do, I will suppress the Z translation for the part to local coordinate system constraint. As we can see now, the part has now indicated it follows something, it follows local coordinate system 2, and it has some degree of freedom on its own. If we do the degree of freedom, it's indicating 1 translation degree of freedom. So this is some situation. I have suppressed the constraint between the local coordinate system and the part that is translate Z, and we have indicated that this degree of freedom is the part's individual degrees of freedom. If I suppress that and I then unsuppress that and I suppress that, why? And currently it becomes even more strange, because Y translation, the same as Z translation, is independent of the X translation. So why it is now indicated as this part has 2 degrees of freedom, although the X is all the time is following this local coordinate system, and Y is in the coordinate system part relation. So why now? How this situation when I suppress the Y translation is different from the when I suppress the Z translation? Now this part has indicated 2 degrees of freedom, and if I change that and suppress also independent of X, so now this part has only 1 degree of freedom. So this is totally, I cannot find any logical explanation why Z-axis is less favorable than Y-axis. So the axis should be equal. Why it is working differently when I suppress Z and then when I suppress Y translation?